So looking at f and g, I have on the numerator 5 times a times x. Don't need to do anything there. I could separate those. Those are not together. They're just side by side by side. No different than putting 4 of you in a group. Okay? You're just side by side by side. When you leave this class, you all go your separate ways. Right? Now, a plus sign in math, you're joined together. It's kind of like you're married, you know, so you're going to get all your classes together. And now 15a plus 10a squared, the GCF is 5a. Now 5a are now separate. Okay? You could do anything you want with 5a now. But what's left, see, 5a times what is 15a? That'd be 3. And 5a times what is 10a squared? That'd be 2a. Now 3 plus 2a are still joined together with a plus sign. So you can't cancel a 3 plus 2a unless there's a 3 plus 2a up there. But 5ax, 5a, those are all separate. You can cross off any like terms. The like terms are 5 and 5. Now you can't cross this a with that a because 3 plus 2a is together. But this a and this a you can cancel. And what's left over is x over 3 plus 2a. Okay. For g, I don't know how often I see this. Here is the most common mistake. They go cross off. And they cross 2z squared over 2z squared, and they cross them off. You cannot do that because 2z squared is joined together with 4z, and this 2z squared is joined together with 10z. But what you can do though is pull out what you can. So what is the GCF of 2z squared minus 4z? 2z, right? Now 2z are separate. You could do anything you want with those. But what's left would be what? Z minus 2. So z minus 2 is still joined together. 2 and z are separate. And then down here, what's the GCF? Another 2z, leaving z minus 5. So I could cross the 2 off. I could divide out the common factor z. And my answer is z minus 2 over z minus 5. I don't need the parentheses because there's nothing in front of z minus 2. There's nothing in front of z minus 5. So my answer is z minus 2, z minus 5. So what happens when you get to problems that are not GCF? You may notice that these look a little different. There is no GCF here or here, and there's no GCF here or here. Okay? And so what we're going to do on those, do you guys recognize that how to factor this? Y squared plus 7y plus 10, do you remember? It's what? It is in standard form. So how do you factor a trinomial, quadratic, where a is 1? No, not synthetic. Remember this? So it'd be what? 10 goes up here, 7 here. So two numbers and multiply to 10 and add to 7 are 5 and 2. So I get y plus 5, y plus 2. And then how do you factor y squared minus 25? Quadratic. Well, it doesn't have to be quadratic to do this method. What do you do when you have a perfect square with a minus? Remember the formula? You break y squared into y and y, 25 into 5 and 5, plus minus. There's no I because this is not a plus, right? So that is y plus 5, y minus 5. And so y squared plus 7y plus 10 And again, you cannot just cross off y squared and y squared, because all three are together. That's a trinomial. These two are together. That's a binomial. The only way to divide out common factors is to factor them out. And so y squared plus 7y plus 10 makes y plus 5, y plus 2. And y squared minus 25 makes y plus 5, y minus 5. Are there any common factors? Y plus 5. Any other common factors? No? So then my answer would be y plus 2 over y minus 5. Okay, so I did that one for you. I want you to try I, which is very, very similar. The only difference is that this is a perfect square, where both of these are quadratic trinomials. Okay? And when you're done, you should get something that looks like that. Okay? So go ahead and try it.